Hey everybody, you're looking at Brendan Herring, and Brendan is going to drum for us a little bit today so we can demonstrate mic placement. Brendan, say hi.
Hello.
All right, and Brendan, will you talk just a little bit about when it comes to getting the drums ready before a recording session, is there anything that you should be thinking about? How do you worry about the source before I start worrying about the microphones and the tones and that sort of thing?
Well, yeah, I mean, just comfortability. It's like if the set feels comfortable before we put the mics on, and make sure that nothing's gonna get in the way of my sticks, and then after we put the mics on, make sure I'm not hitting any sticks or hitting any microphones with my sticks. Just make sure I feel comfortable on it.
So I'll zoom out a little bit and you can sort of mess around and see if you're starting to feel comfortable, okay?
Cool. Floor tom's good. We're not gonna use the rack tom, so I don't think. Well, I mean, we might use it, but biggest thing I would say is just the rack tom. Then I brought a second snare, just in case that.
Tell everyone why you'd bring a second snare, what the benefit of that might be.
Just in case you want to get a different tone, or sometimes, especially a kit that's been set up for a while that's being played, such as the one in Studio A, sometimes the snares on the bottom of them get a little worn out, and if you hear it, you get that zzz out of it. It's easier just to bring a second snare instead of going to Guitar Center and grabbing a whole new bottom set of snares, because they can get pretty worn out. Which I don't think these are too bad. Especially this snare that has two or a set of snares going across it.
Will you take that off the stand and kind of show us what you're talking about when you talk about the snares on the bottom here?
Yeah, for sure.
Or you can use this other snare if you want to take it out of the stand.
So
I'm gonna zoom in on this here.
that good?
Yeah, you're great, perfect.
So right here, sometimes while being played and it's being changed out, these are easily bent. So even if they're not fully touching the membrane head, which is the bottom side of the snare, if it's just a little bit off, you'll get a buzz, which will mess up the whole entire recording. And so I brought one that I know that we actually just recently used, and that I was messing with like yesterday to make sure that I got a good sound out of it.
Go back and forth between the two.
You have first one, second one.
Mm-hmm.
That sounds a lot lower.
Yeah.
So depending on the track, sometimes you would want that thicker sound. But yeah.
All right, so this is the Shure Beta 52A, and we're going to put it on the kick drum. Okay, so when we talk about the difference between that fundamental frequency, those, that 40, 50, 60, 70, 80 hertz, that the kick drum, where the kick drum's power and body is, and the difference between that and the attack, that 6, 7, 8K range, where the beater makes contact with the head, if I only have one microphone, I'm going to have to position that microphone to get the balance of those two portions of the signal that I am looking for. So I've got one microphone here, the Beta 52A. I've got this stand. I'm going to go ahead and connect the mic to the stand. And you'll notice the kick drum, and this is fairly common, that the kick drum has a hole cut in this audience side head here. The primary function of having a hole in this front head is to get a microphone inside there. Now, that's not to say it doesn't have other advantages with the way the drum head vibrates and things is going to change if the air is contained within the shell of the drum, or if the air is able to move out of the drum head like this, it's going to have some effect on the sound. But the reason we started putting front holes in these drum heads is to get a microphone inside the kick drum. Now that's going to do a couple things. One, it is going to give us less bleed because the shell, the outer part of the drum here, is naturally acting as a barrier, keeping some of the other sound from getting into the microphone, right? Or at least in some way preventing a little bit of that bleed from the surrounding drums and any other instrumentation that might be nearby from getting into the mic. But the other thing, and this is what I really want to focus on, is that the sound changes the further the microphone goes into the drum. And it changes in this way. As the mic goes further into the body of the kick, you are going to be getting more of that attack, more of that tick, more of that high frequency signal that brings the ear, or that makes the ear focus in on the kick drum and adds definition as the arrangement gets dense. If you pull the mic further out of the drum, you're going to be getting less attack, but more of those sub-frequencies, more of those fundamentals, that 40, 50, 60, 70 hertz range, that gives the body and the power to the kick drum signal. So if we're only using one microphone, it's our job as an engineer to find the spot between deep in the drum and farther out of the drum that has the blend of that attack and that body that we are looking for this particular song and arrangement. Now, some engineers will just use two microphones, one that they jam inside the drum for the attack and one that they leave outside of the drum for those lower frequencies, and then they will either blend those two mics at the console using a bus to combine them before the recorder, or they'll just record each mic on a separate track and blend during the mix to come up with the amount of attack and body that they want. The advantage to working that way is that sometimes when we're getting basic tracks, we don't know what the final arrangement is going to sound like. We're not sure all of the parts we're not sure how dense the track is going to be by the time it is done. So retaining two separate kick mics does have that advantage. If, however, you have some vision and some taste and some idea as to what you want the kick drum to sound like in the final mix, you can capture it with one microphone, or you can bus two microphones together before the recorder and have your vision for the kick drum retained in the recording, which is especially helpful if you are not or may not be the person who is going to end up ultimately mixing this thing. So for our purposes, we're going to start with this microphone fairly close to the audience side head here, because we'll be recording actually two tracks today, and I'm not sure which one we're going to use in this demo video, but we are probably going to be working with a somewhat more open arrangement for the first of these tracks that we're going to record here. All right, so I'll start with just sort of the nose of the microphone inside the kick drum here, and we'll listen to that, and if I decide when I hear it in the control room that I want to move, that I don't like the sound, my first plan is going to be to come out here and move the microphone. Before I reach for EQ, before I start compressing, anything like that, my first plan will be to come out here and move that microphone either further in, further out, and we'll see what that sounds like. The microphone we're going to put on the snare drum is the SM57 right now. Now, I've chosen a dynamic microphone for both the kick and the snare, and to jump ahead a little bit, I've chosen dynamic microphones for the toms as well. These are our close mics. So one thing you know about drums is they're a very loud instrument, right? The reason we're going to use dynamics as our close mics is because we're putting the microphone so close to the head of the drum. In the case of the snare, we'll leave the diaphragm of the mic really within an inch or an inch and a half of the head of the drum here, which is not a place you'd want to put your ear for sure, because it's an incredibly high amplitude area. But the reason we're putting it so close is, again, to try to eliminate bleed, right? By getting the microphone that close, it means we're going to not have to turn up the gain much. And because the SM57 is also a cardioid microphone, I will try to position it in such a location. In fact, I'm going to put this so that the back of the mic, which is the least sensitive part of this mic, is going to be aimed between the hi-hat and this cymbal here. So what I'm trying to do in aiming it like that is get as little of these two sources into this microphone as possible. And by getting the microphone closer to the head of the drum, I'll get more of that direct signal and less of these bleed. So I'm going to start by putting the mic on the boom here. And again, I'm going to try to position the rear of the microphone so that it's angled right in between the hi-hat and this crash cymbal. And I'm going to tighten the mic down so that the head of the drum, I can usually fit about these two fingers between the diaphragm of the mic and the head of the drum. I like to think, imagine that the microphone works like a flashlight, okay? So flashlights are, we'll say a flashlight is cardioid, which no one would ever say, but you know what I'm talking about when I say that. It shines in one direction. And if this were a regular flashlight, the closer I get the flashlight to the head of the drum, the tighter that little circle of light becomes. The further I pull the flashlight away from the head of the drum, the wider that circle of light becomes. And you sort of understand that inherently, right? So ideally, I would want to move the microphone high enough that that circle of light, which is really the most sensitive area of the cardioid microphone, is covering the whole head of the drum, because different parts of the drum head sound differently. The center of the drum head is our fundamental frequency, which on a snare drum is usually in the 250 or 300 hertz range. The edge of the drum head has high harmonic information. It has a little bit more of the brighter overtone characteristic, which on the snare drum can extend well up into the top octave of human hearing. So ideally, if this were a flashlight, we would position the flashlight high enough that area of sensitivity was covering the whole head of the drum, and we get all parts of that. The trouble with moving the microphone up that high is that it's going to get more bleed, right? So we move the microphone closer and closer. But if we were to just position the microphone right here, the chances of the drummer hitting that mic with the drumstick it's almost a certainty, right? The microphone is in the drummer's way. So we're going to move the microphone off to the edge of the drum, but as we move the microphone off to the edge of the drum, we're losing that fundamental frequency that comes from the center of the head. So the solution we're going to use is to tilt the microphone. And again, if you imagine this is a flashlight, as you tilt that microphone, it widens that pickup circle, right? It widens that area of light so that it is extending over a greater portion of the drum head, but we're still keeping the microphone close enough to eliminate those bleed properties. And we're going to place it on this back part of the snare drum, furthest away from the drummer, so that that cardioid pattern is working to our advantage to keep these two elements out of the mic. Okay, and we're going to position a second microphone on the snare drum here, and the second microphone is going to go on the bottom head of the drum. Aimed in a similar way as the top microphone, but the snare drum, because Brendan was telling you earlier, has those metal strips across the bottom head that do two things. One, they stop the resonance, so it's a shorter sustain than our other drums. And the second thing they do is they produce those really high frequency, those overtony, scratchy parts of the sound that give the snare its characteristic snap, right? So the bottom head has those actual snares on it, those actual metal strips that produce that snap, and the top head has that attack, that part of the signal. And so you're getting a very different sound between those two heads. So we're going to use two microphones, one on the top that we've positioned here, and then this second microphone on the bottom. Now that we've put two microphones on one source, anytime we have two or more microphones on one source, the thing we should always be thinking about is the phase relationship, that time relationship between those two microphones. Now, especially in this case, because you've got two diaphragms that are aimed in opposite directions at the instrument. That means those diaphragms, when we make contact with the instrument, are probably going to be moving in opposite directions to one another. One is moving into the mic and the other is pulling away from the mic at the same time, and that means the chances that we should change the polarity of one of those two mics become high, and we will listen to that and determine if that's true or not when we get into the control room. But it would usually make sense that we're going to hit that polarity button, flip the phase of one of those two microphones, right? All right, now we're going to go to the toms, and we're only going to mic the top head of the tom. Toms don't have those snares across the bottom head. So we're going to mic the top head. We're going to use another dynamic microphone because, again, we're getting this mic close to the head. I'm not going to put it quite as close to the tom head as I do the snare drum, just because, in my experience and opinion, toms just sound a little bit better with a little more air to the signal. So I'm going to leave a little more distance between the diaphragm of this microphone. This, by the way, is a Sennheiser 421. The 421 has a low cut filter, a bass roll off that SM57 and Beta 52 do not have. So, and this bass roll off has sort of an odd labeling on it. It has M on one side and S on the other, as opposed to telling us, say, no cut and cut. The M, according to Sennheiser's literature, stands for music, and the S stands for speech. The speech position would mean the low-cut filter is on. It is rolling off those bass frequencies. And the 421 has an exceptionally wide low-cut filter that starts around 500 hertz, and again, by my opinion, sounds bad. It's just not a very good sounding filter. So we're going to leave this in the M position. It's my thought that I always leave this in the M position on this particular microphone, just because it really thins the sound in an unpleasant way to my ears. Okay, so I'm going to put this on the stand and aim it in a similar way that we aimed the 57 on the snare, but on the high tom here. And another thing to know about the 421 is this clip has a button here, and that button is on the bottom of the microphone, and if you touch that button, even gently, that clip slides off. So sometimes you got the mic on the stand and you just want to go to reposition the mic, but your index finger accidentally hits that button and the mic will fall off or the clip will fall off. If the clip is on a stand, then the mic's going to fall off. And you really want to avoid that. It's not a great design, but they've been manufacturing this microphone for decades and they haven't changed that clip yet, so I guess we're stuck with it for now. I'm going to come around to the other side of this here. Raise this up a bit. I don't know, am I still in frame there?
Yep.
I'm going to raise this up a bit so that I can reposition the microphone. And again, we're going to be using the cardioid nature of this mic to our advantage to get as little bleed as we can from this crash cymbal here. So I'm going to angle it just a little so that the back of the mic is just slightly angled towards this crash cymbal. And, you know, and we've got just a little more space between that diaphragm and the drum head than we did with the snare. And we will listen to that and determine what we think that sounds like. Our big concern is that it stays out of the hit area on the drum head here so that Brendan doesn't make a direct contact with the microphone. One more thing, and I talked about this in our guitar recording video, but this microphone is a front address mic. This is the sensitive area of the mic. You see this and you might think you try to make noise into this part here, but the sensitive part of the microphone is right here where it says Sennheiser across the front of that grill. So we would call this a front address microphone. All right. I'm going to put the same configuration here on the low tom with another 421. All right, the next thing we're going to get are the overhead microphones on this kit. I've brought with me, these mics are manufactured by Microtech Gefell. They are condenser microphones called M930s. They're cardioid microphones, so you have to know which side is the front, which Microtech Gefell has not done a great job of labeling the front of these things. Typically, the front is the side that has the manufacturer's logo on it. In this particular case, that's not true. The front is the side that has a little indented dot, a little dimple in it. For whatever reason, it feels like that's about the only microphone I know of that is set up like this. So, the M930s are going to go on these stands, and anytime you're creating a stereo image with two microphones, there are a whole variety of ways that you can position those two mics that are going to change the stereo field and the spread of the sound. In fact, when you get to Engineering 2, which with a little bit of luck will be actual human beings in a room together talking to one another, breathing on each other. There are good and bad parts of that, of course. But when you get into Engineering 2, the very first part of the semester, the very first chunk of the semester is dedicated to two mics and the positioning of those two microphones to create a whole variety of different stereo images. And you will listen to the difference in positioning these two microphones. We're not going to do that right now. I will save that for the fall semester with Swihart. But I'm going to put these two mics on their stands here. And when we go to plug these microphones in, we're going to need to make a decision about what we are considering left and what we are considering right. Now that is the decision between drummer perspective, meaning this is my left and this is my right, hi-hat on my left and ride cymbal on my right, or are we doing it from your perspective, from audience perspective, which would be reversed, right? Where the ride is the left and the hi-hat is the right. For our case, we're going to do this from the audience perspective, especially because there's a video camera looking at this. It makes more sense when I start panning if the left that you hear, provided you're watching on a television that has a stereo speakers, the left that you hear matches the visual perspective that you're going to see. So we're going to call this the left and this the right. When I label it in my Pro Tools session, I'm actually going to label it overhead ride and overhead hat instead of overhead left and overhead right. That way, if someone other than me is mixing these tracks, they will know what I am considering the left and what I am considering the right. And then we're going to move these microphones up to get a little bit of room sound. It's not a terrible idea to actually have, especially in a room like this, to actually set up room mics that you can blend in to determine the wet-dry blend, the amount of room ambience compared to the amount of direct sound that you're getting. If you don't set up room mics, then your direct to indirect sound ratio is going to be determined almost entirely by the height of the overheads from the drum kit itself. The higher they go, the more indirect sound you get. The lower they come, the closer the sound becomes. What's the correct blend? Entirely dependent on genre and taste. If you are recording big hair metal, arena rock kind of stuff, you generally want bigger, wider room sound. If you are recording, 70s funk, you generally want very close, tight sound, and everything else can be somewhere in between. All right, so I'm going to move these microphones up a little bit. I'm going to bring them closer and angle them in such a way that they're creating sort of a stereo spread over the drums here. Now that we've got the mics on stands, we're going to run cable to them. The thing you want to make sure is that your cables are laid out neatly, but unlike the live stage setting with Mr. Mixer, we're not going to use gaff tape and tape these cables down to the ground, which means, yes, they are a tripping hazard, but we're all going to be really hyper aware of that, and we're going to make sure there aren't cables dangling in the air. And the reason we're not going to tape them down is because very often in the studio things move. We listen to the way it sounds and we want to experiment a little and move it to another location, and so we need to leave these microphones so they're easily movable. I'm going to plug the XLR into the panel and then carry the slack with me over to the microphone. The slack on the end of the cable will stay at the mic itself. And so you see I've got the slack that is left coiled neatly at the base of the mic stand, so that if at any point I want to move this mic, I can grab both of these things and just carry it with me and add more cable as I need to. And the cable is just very gently, lightly wound once around the base of the stand, just so it's not dangling from the floor up to the microphone, which is going to become a bigger deal as we get to these mics that are a little bit higher off the ground.